Thank you. Well, g'day. I'm from Australia. Just like to thank Mark for getting you used to my accent. Hopefully you'll be able to understand me. No. It's my pleasure this afternoon to try and assimilate all of the wonderful science that has been presented so far this morning and this afternoon and try and put it into a bit more of a practical context so what you can take home with you when you leave Taipei. My presentation will quickly talk about the factors influencing performance and gastrointestinal health, and then I'll put nutrient sparing in context, and hopefully then start to elaborate on some of the practical approaches that we can use for nutrient sparing. A conclusion, and hopefully you'll generate some questions that in the panel discussion at the conclusion of this session we can address. In terms of feed efficiency, there are many things that influence feed efficiency, and previous speaker, Dr. Ferry, covered many of these. All of these things that we do on farm, through management, etc., have a significant bearing on feed efficiency, and they're all interrelated. If we get housing wrong, again, as Dr. Ferry said, we can have a big impact on feed efficiency. But we can have the right housing, the right environment, but the wrong staff, the wrong biosecurity program. So all of these things will impact on feed efficiency. And then from my bio, you will see I'm a nutritionist, so I'm particularly interested in feeding. And we recognise that feeding also has a big impact on feed efficiency. Feed intake, digestibility, availability, and the choice of ingredients and nutrients. And when we look at all of these, what we actually see is that all of these things that we're doing really just simply impact on gut health. So all of those things we do on farm have a direct impact on gut health. In terms of nutrient utilisation, you'll see in my presentation, as in many others, we have lots of little cartoons. Here's a very simple one. But in the perfect world, we have feed going in, quite a lot of feed, and hopefully a very little bit of feces coming out the other end. And along the way, nutrients are diverted into maintenance. So this is allowing the animal, ourselves, to breathe, to pump our blood through our system. Hopefully there's a lot more nutrients get diverted into growth, reproduction, so meat, milk, eggs, wool, and for the reproducing animals, the developing fetus, and then with a small amount going into unproductive processes or metabolic losses, the inflammatory response that Professor Niewald, for example, talked about. So that's the perfect world, that's how we'd like to see it. Unfortunately, we don't live in the perfect world, and what we see is probably the real world. And in the real world, same amount of feed goes in, but we have a lot more feces coming out. The maintenance component is still the same, but unfortunately we have often less nutrients available for the growth and reproductive processes because more nutrients have gone into being diverted into these unproductive purposes or these metabolic losses. And so this hopefully gives you an introduction into what nutrient sparing actually is. And simply, sparing means freeing up or saving from a particular purpose. So therefore, a long-winded definition of nutrient sparing is that this is applying strategies to optimize the gastrointestinal tract and the metabolic environment within the GIT to ensure that more nutrients are digested, absorbed, and then utilized for productive purposes, with then less nutrients being diverted into these unproductive processes and then being excreted. So there's many reasons for metabolic losses, and these include formulation issues, type and quality of the raw materials that are used, and the stress and immune system activation that we've heard a lot about today already. And of course, there's going to be combinations and synergistic activities between all of those. And I'll address all of these things in the subsequent part of my talk in terms of how we can use nutrient-sparing techniques to account for these. But just before I do that, I just wanted to talk about the importance of the gastrointestinal tract in nutrient utilisation. And searching YouTube, found this nice picture. And if we just assume that this bucket of gruel here is equivalent to our limited daily nutrient supply. And I think this is actually quite a good picture, because what actually happens is that this first guy here, he's the gastrointestinal tract. He's first in line. He takes whatever he wants. So he's got the first lot. After that, energy, nutrients have to get utilised for maintenance. And then we also need energy and nutrients for heat regulation, a little bit of walking, etc., and fighting inflammation. And then our business, what we're interested in, is growth and reproduction. But growth and reproduction is a long way down the queue. So if we want to have effective growth and reproduction, we've got to make sure that all of these dogs, all of those processes are well satisfied and we actually have some left over. Because if we use too much for the gastrointestinal tract support, then there's not going to be very much left for growth and reproduction. So some of the metabolic losses in terms of formulation, there are many, and those that are active nutritionists will understand many of these, but we can have things such as imbalance in amino acid ratios. We can have imbalance in the energy to amino acid ratios. Sometimes we can have too many or too little nutrients. And again, this all has a big impact. Often we might have the right feed, but it goes to the wrong animal. And also, what animal is really being targeted? Have we got the right feed, but it's going to the wrong age pig? The creep feed is now going to a grower pig. The starter feed is being fed too long, and it's going to a withdrawal animal. But when we look at which animal is being targeted, we know that Cobb, Avigen, all of these broiler companies, layer companies, have quite detailed breeding standards, the nutrient standards for their breed. And the same with PIC and all of the other pig breeding companies. So we know as animal scientists quite detailed what is actually the ratio, the level of all of the nutrients to support optimal growth. But when we get into the real world, this is what we actually see, that by definition, if we supply the average animal at 100% of the average animal's nutrient requirements, by definition, we're only meeting or exceeding the nutrient requirements for 50% of your herd or your flock. So generally what nutritionists do is they put a safety margin in there. And they might say, well, let's formulate to 125% of the average animal. And by doing that, we now can get up to 88% of the nutrient requirements of animals being met or exceeded. But we still have this little bit of tail out here where those animals will never get the nutrients that they need for effective growth. And this has big impacts on uniformity. Another important concept to understand is if we look at protein deposition, so that's how much muscle, meat we're making, there's a direct relationship, obviously, between protein deposition and protein intake, such that the more protein we eat, the more protein we make. Quite simple. But at some point, it does get to a point where it doesn't matter how much protein you eat, you cannot make any more protein when you have this existing energy level. And in some cases, you actually have quite a lot of metabolic stress as the animal tries to excrete all that extra protein because it can't deposit it. And you can have negative feed intake, negative FCRs, or poorer FCR when you reach this sort of level. So what do we do in terms of increasing protein deposition? we have to increase the energy level a bit more. And then we can now start to deposit more protein. So as much as this talk is on protein utilisation and the protein economy, the take-home message is that feeding more protein will not increase muscle mass unless more energy is made available. So doing techniques to allow more amino acid utilisation to occur doesn't always end up with a result unless we are also aware of the requirement for extra energy. Many of you have probably seen this Liebig barrel theory, where we talk about a limit, and it's limiting amino acids. It's like a barrel. If we fill this barrel up with water, the water can only go to the level of the limiting pail, the limiting stave. And in this case, lysine is the most common limiting amino acid in animal nutrition. So it doesn't matter how much of all of these other amino acids we have in the system, the animal cannot deposit protein because of the limit to lysine. So what we do is we add more lysine, either synthetically or through choice of protein. And by doing that, we now can improve animal performance until the next limiting amino acid starts to occur. And that could be threonine, could be leucine, methionine, depending on what system you're in. And we can keep increasing the limit until it becomes financially unattainable, but this is what we're trying to do. The problem when we start using byproducts is that often byproducts are very low in lysine, so we keep formulating in more byproducts and we keep loading up with all of these other amino acids that don't get utilised. They end up in the hindgut, become a source for bacterial growth in the hindgut, particularly necrotic enteritis. So we've got to be able to balance this limiting amino acid. And again, this gets down into our nutrient-sparing approach. In terms of raw material issues that can impact on metabolic losses, the type and quality of the raw materials are used, as I said, increasing use of byproducts, but the limited knowledge on the availability of the nutrients within a raw material. It's quite easy to measure protein, quite a simple number, crude protein, measure the nitrogen, multiply by 6.25, presto, there's your protein content. But that gives us no indication of the amino acid availability within that protein source. And you saw before from those COB and PIC breeding standards, the animals know, the scientists know, exactly how much of each of those amino acids is needed for effective growth. In raw materials, we also have the presence of anti-nutritional factors. There's the presence of mycotoxins, and we also use in our industry a lot of enzymes and uplifts. But if we are using enzymes to break down a substrate, if that substrate is not present, then we don't get any uplift. So again, how well do we know our raw material bases in terms of the phytate, the NSP levels, beta-glucans, etc.? This is some examples borrowed from Keith Benke from the US, but it represents the raw materials commonly used in Asia and just shows over a long period of time the variability in a lot of raw materials. So when we look at crude protein in dried distillers grains, we see this huge variation. So when we're making feed on a daily, weekly basis, what number do we choose? Similar for corn and soybean meal, again the common ingredients imported into Asia. Huge variability, season by season, but even on the one day, we can have a variation of 3 or 4%. And the same with soybean meal. Which number do we use? This slide was shown previously, but we also know that mycotoxins have a strong impact on the effectiveness of the gut. We can have intestinal permeability being impacted by deoxynivalenol, cell proliferation, mucus production, many aspects. So again, contributing to potential metabolic losses. Stress, we've heard a lot about stress today and the role of stress and immunity. And as we've heard, the gut is the largest immune organ in the body, and it's exposed to more bacterial cells than there are cells in the whole of the body. Stress results, as we heard previously as well, from many factors: host, microbiota, toxins, vaccinations, environment, etc. And we also know that the immune system is overstimulated, amino acids and energy are being diverted into the inflammatory response, those acute phase proteins, rather than productive purposes. And as Professor Niewald adequately shown this morning, we know that AGPs were anti-inflammatory, so when we talk about AGP replacement, we have to be conscious of why the AGPs were used in the first place. We've had lots of talks today about the immune response, so I've got my own little quiz here. I've got a very rare pencil sharpener, so for the first person that can give me the overview of the immune response, you can win this very rare pencil sharpener. No takers? Okay, I'll have to do it myself. But as you can see, it's very simple, the immune response. So I was talking to Mark Guinemont, and he said that people are really enthusiastic about this seminar today, and he said there's no trouble going a couple of hours overtime, and we put dinner back for an hour or two. But what we do know is that when the microbe impacts on the intestinal epithelium, a whole lot of complicated processes happen, and we need to be mindful of that. And we've talked a lot about the impact of the immune response, but there's been some few nice papers in the literature about what actually happens when you challenge pigs with lipopolysaccharides. So it's just not a theoretical assumption that LPS or stress has an impact. This nice work done by Lou, they challenged the animals with LPS or endotoxin, and they looked at a number of different compounds, interleukins and prostaglandins, which give you an indication of the amount of inflammation, looked at cortisol, which gives you an indication of the body's reaction, and insulin-like growth factor. The higher the insulin-like growth factor, the more growth. And when they looked at these, we saw that with a challenge of LPS, huge increase in interleukins, prostaglandins, cortisol, and a reduction in IGF, showing a lot of stress on the animal. And then they quantified that in terms of what actually happens to the daily gain. And you can see that daily gain was significantly impacted. Daily feed intake was also affected. Interestingly, and as we see many times in research, if people just focus on FCR, if you just saw these results, you might say, oh, FCR wasn't impacted, therefore stress has no effect. But again, we have to be mindful that we have to look at not only just FCR, but also the impact on daily gain. So we know from this sort of work and others that stress has a biological and commercial impact on performance. So what are some of the nutrient-sparing approaches that we can use with feed additives? Well, there's many commercial contenders. We know of enzymes, acidifiers. In your poster booklet and outside, you'll see many examples of the use of our product top 3. Mycotoxin deactivators, oligosaccharide-based products, probiotics, prebiotics, and symbiotics. And due to limitations of time, today I will only talk about probiotics and phytogenics. But we also have to remember that nutrient sparing is only one contributor of overall animal performance. And I'd also like to remind you that nutrient sparing is only one mode of action of these feed-based additives. So when we look at using a feed-based additive to improve animal performance, what are we really trying to do? And what we want to use is a feed additive that will improve performance, livability, meat quality, the other commercial parameters. And how it does that can be many different ways. Those additives can improve palatability, endogenous enzyme secretion that improves digestibility. We can also use those to have gut microbiota optimization. Interestingly, if we increase intake and also increase nutrient digestibility, we have a double whammy. And we've also talked a lot about reducing intestinal challenge and inflammation. And depending on the mode of action and the system that you're working in, Some of the feed additives may do all of these, and there will be some degree of additivity. In some cases, it might only just function on one or two of these aspects. But the end result of using any feed additive hopefully should be to improve this aspect. I just want to touch on inflammation, and Professor Niewald mentioned this NRF2 and NF-kappa B system. And when a cell, represented by this yin and yang symbol, is impacted by a stressor, there's a whole cascade of reactions happen in this cell. And we get production of these pro-inflammatory cytokines. Cytokines, fancy name for chemicals. And these lead to inflammatory process. On the other side of the equation, we can have production of anti-inflammatory proteins or cell protection proteins regulated through this NRF2 system. And from a suppression of inflammation approach, what we want to do is stop this one and encourage this one. And that's the mechanism of anti-inflammatory. So what are phytogenics? Well, I think most of you know that phytogenics are functional feed additives of plant origin. And they can be quite simple in terms of just using a herb and a spice, or we can extract out the volatile essential oils from those herbs and spices, or we can go down to the next level and start looking at the essential oil compounds, and in this case we might be looking at thymol or carvacrol, which are part of thyme oil or oregano, which come from thyme or oregano. So again, there's a different level of phytogenics. We can also have non-volatile components, and these are things like bark extract. So phytogenics can be quite a complicated area, which often leads to the confusion in the marketplace. Traditionally, phytogenics have been used for their flavour properties, particularly in pig and cattle diets. But again, as identified by Professor Niewald, we're now focusing a lot more on the biological activities related to digestion of the phytogenics. And the main functions that phytogenics are involved in are antioxidant, anti-inflammatory, they can stimulate gastrointestinal secretions, and some antimicrobial properties. This is some data just showing that we can increase the amino acid digestibility with phytogenics. This study was done in pigs, and we saw improvements in all of the amino acids, digestibility, and significant in most cases, except perhaps for the methionine. So again, we know that phytogenics can improve amino acid digestibility. One of the other advantages of phytogenics is that compared to antibiotic growth promoters, in this case bacitracin, and we're looking at a log scale here, this particular study we had a negative control, no antibiotics, the positive control contained bacitracin, and then we had the phytogenic. And for all intents and purposes, the phytogenic did as good, if not better job, in terms of controlling salmonella, coliforms, anaerobic bacteria, Clostridium. But what the AGP cannot do, but probiotics do, is increase the lactobacillus. And again, from Daniel Petrie's presentation, we know that lactobacilli are very common. We've just still got to work out what they actually do. So again, phytogenics can replicate AGPs, but also have additional functions. In terms of phytogenics' ability to reduce intestinal inflammation, I talked about the NF-kappa B, and what we can use here is various inflammatory markers in a cell culture, and we look at the amount of mRNA that's coded. If mRNA increases, more of those proteins are made. And in this particular model, we had no inflammation to these cells, we gave inflammation, and then we looked at phytogenic. So this is the negative control without inflammation. We increased the inflammation challenge, and we saw that the production, the expression of this mRNA was increased. So more NF-kappa B genes were activated, and we could correct those for these markers by using a phytogenic. So again, this shows that we can stop that left-hand side of the yin and yang. On the right-hand side, similar sort of model, using different gut protection markers. With phytogenics, we're able to show that we can stimulate the upregulation of those good genes. So when we use quality phytogenics, hopefully you can see that phytogenics can spare nutrients. They do this by decreasing the inflammatory processes, improving gut protection, increasing antioxidant capacity, and as mentioned a few times today, improving gut integrity. And the end result of all of this is that we have relief from intestinal stress, so more nutrients directed towards performance. Probiotics, we talked a lot about probiotics, and there's a multiple mode of action that occurs with probiotics, and this has been discussed. But when we're using phytogenics and other techniques for nutrient sparing, what can we do? Well, there's a number of scenarios. We can take our standard activity where we have a normal feed cost that gives us normal performance. We can then have a higher feed cost by adding in an additive, which will give us higher performance. A third scenario is to look at down-speccing and achieving a lower feed cost to retain the same performance as we had up here, or we can go same feed cost with the additive and achieve higher performance. So again, 4 different scenarios or 3 practices to incorporate phytogenics. And quick example of an experiment that we did to demonstrate that we can actually nutrient spare with phytogenics. In this particular study in poultry, we had 3 a standard formulation, phytogenics, and control. The standard formulation had an antibiotic growth promoter in it, and then we reformulated the diet to be 95% of the ME and digestible amino acids. And what we found is that the standard diet performed better than the restricted diet, as you would expect, and that was a reduction of about 4% in terms of decreasing the standard diet. But what we saw was that by adding in the phytogenic, we can return most of the reduction in down-specking of the nutrients by the use of the phytogenics, demonstrating the nutrient sparing effect. And the same thing happened with FCR. And when we look at production index, sure, it was lower because we had 95% of the nutrients, but we actually could have a better production index and recovered by using the phytogenic. So the conclusion from this trial, and there's some other ones that were shown in the posters, is that nutrient sparing effects can be effective with digesterom. We can down-spec the diets, which we know reduces broiler performance, but we can recover most of that performance using digesterom. A couple of quick things that I just want to also talk about. We've focused on individual animals, but in reality we're looking at flocks or herds. And when we look at the distribution, again as shown in Daniel's talk, variation is quite important, and this is a typical distribution of our animal performance when we look at weight. It's a skewed distribution because we don't have too many heavy animals, but we have a long tail. And what we know is that the animals at this end, these are the animals that have good gut health, they're easy to manage, and they make us a lot of money because their FCR is very high. We can't identify those in a shed of 30,000 birds, but we know they're there. What we also know is that the animals down here, these pigs or birds, these have poor gut health. And in our piggery, we might only have 5 animals that have diarrhea, but they are impacting on the other 150 animals in that pen. So a small number of poor performers are having a big impact on all the other ones. And what we see when we put a Biomin solution together is that we reduce the number of animals in the tail, but generally these ones, you can't improve genetic performance of animals. There's no additive in the world that will make your animals grow better than their genetic potential. So it's foolish to say that we're going to have a much bigger impact up here, but we certainly do have an impact here. And typically, that results in an average weight increase. Again, focusing on one metric is not necessarily the best idea because sometimes this average weight increase might not be realised because a lot of these animals which would otherwise have died are now being sold. So the average weight may not have increased dramatically, but we're selling more kilograms of animals. So again, the importance of measuring weight and FCR in our systems. So in conclusion, Mr. Chairman, I hope to have shown that improving amino acid utilisation is a key component in driving the protein economy. Metabolic losses occur in animal production systems for a number of reasons. And if we can understand and utilise the nutrient-sparing approaches, we can significantly improve the performance, profitability, and sustainability of animal production. And hopefully, Biomin has shown you that we have a number of effective feed additive solutions to facilitate nutrient sparing. And finally, Mr. Chairman, I just hope that if you don't remember too many things about my talk, that next time you're feeding your dog, that you'll realise that feeding the dog has an impact on nutrient sparing. Thank you very much for your attention.